Hi, AP Stats. So this is the Chapter 7 review. As I've discussed earlier, most of these questions are based on sample proportions, sample distributions, finding the means, and things like that. Standard deviations with two proportions combined, with two sample distributions combined, and all that good stuff. So make sure you get your calculator ready also while you're doing the review. And, I hope this video helps in terms of you guys getting prepared for tomorrow, also going over just checking over the answers and how to figure out the answers to these types of questions here. All right, so for number one, which of the following best describes what is meant by the term sampling variability? There are many different methods for selecting a sample. Well, first of all, let's just go over what sampling variability means. Sampling variability is basically caused by having different samples taken from a population. And they basically differ because it's a sample. You never know what you're going to get. And so based on the samples that you get, there's obviously these subtle differences that's going to be from one sample to the other. The methods of the sampling, well, that's not what we're really talking about. We're really talking about like just the data of this, how the data is going to be different from each of the samples. So two different samples from the same population may have different values of sample statistics. This is actually the one that you want to go for. The sample size can sometimes vary from sample to sample. The sample size should always be the same amongst the samples. Otherwise, you should have different results because, as we have discussed, sample size n really hugely impacts the variability. Convenience samples may not be representative of the population, and population characteristics vary from population to population. These really don't have anything to do with sampling variability because they're talking about populations here. So the correct answer here should be B. I had a lot of students who came to me to ask for help for number two. Now for number two, the correct answer is B, and here's the reason why. You have a sample of, that you're choosing from 2, 4, 6, 8, and you're choosing two of those. So for example, let's say you pick 2 and 4, and you're trying to find out what is the sampling distribution of the sample mean. The word emphasis on sample mean. You are finding the mean between any of these two things. And if you actually take the combinations of all of these numbers, like for example, 2 and 4, the mean of those guys is 3. So one of the events that must happen is the fact that you're going to get a 3 as the result. Look at how A, D, and E, they don't even have 3 as part of your answer. So you can just eliminate A, D, and E right out of the gate and say, okay, between B and C, I have the 3 as one of our results. What's the other possible answer? Well, if you combine, let's say 2 and 6, because it's without replacement, you got to pick 2 of different kinds. You can't pick 2 of the same thing. 2 plus 6 divided by 2, taking the average of those two will give me a 4. When I say sample mean, I literally mean take the two numbers divided by 2, like finding the average of those two. So that will give me 3. This will give me 4. So 4 has to be one of the results that you get. And the only answer that contains that is answer choice B. So quite in all honesty, that's really the only reason why the B is the correct answer here. And you would just move on. Number 3, the histogram shown here, sampling distribution. This histogram is based upon 500 sample size of 500 different samples, each of size n. All 3 histograms were constructed by sampling from the same population, but the sample sizes were different. Smallest sample size means the variability is the largest. So please keep that in mind. That's the relationship. Vice versa, if the sample size is big enough, your variability gets really small. So if we're talking about the smallest sample size, we're obviously talking about the histogram Roman numeral 1 here. Number 4, each one is based on 500 samples of size 25. So luckily, all the size of the samples are the same. But each of the 3 histogram is a result of sampling from a different population. Which of the 3 population samples had the largest standard deviation? Well, if the sample sizes are all the same, then you can't really account for that as the variable factor. What really comes down to is the largest standard deviation. It comes from the population also having the largest standard deviation. So, I mean, you can see how Roman numeral 1 also here, you have the largest spread from the center. Therefore, this is also going to be A. Number 5, for a random sample from a skewed population, for which of the following sample sizes would the sampling distribution mean be closest to normal in shape? So this is not really of a difficult question in a sense that you have basically the normal in shape. You're talking about the central limit theorem. And so that really comes down to, is the sample size big enough or not? So the rule is that if as n is as long as n is greater than or equal to 30, you're going to assume normality here. Now, if you have the choice between C and D, you want to go with the sample size that actually gives you the one that actually has the larger sample size, because the greater the n is going to be, the more closer it is going to be in normal shape. Yes, the variability is going to be low, but the higher the sample size is, the higher probability of a chance that that will be in a normal in shape. And we're talking about closest to normal. So the higher sample size it is going to be, the more normal in the shape is going to be there. And also in the case of n times p equals greater than or equal to 10, as we don't know what probability is going to be. So, I mean, probability can be really small for all I care, but, it could be 0.05 or whatever. But when n is big enough, it can actually account for even the smallest of the probability. So there's a higher chance that it could be normal in shape just because it has a higher sample size. Number 6, what is the standard deviation of the sample mean for random sizes of 100 from population with a mean of 100 and a standard deviation of 80? This is really an easy question because, the sample standard deviation will always be the population standard deviation divided by the square root of the sample size. So we just simply take 80 divided by square root of 100. So that will give me 8. So that's B. For which of the following will the sample mean tend to differ least from sample to sample? Differ least means the smallest variability. So we want to find out the n to be the largest one as possible. So that should be E. Number 8, commute distances for employees of a large company is skewed. Suppose the mean commute distances is 20 miles and the standard deviation is 10. What can be said about the mean commute distance for a random sample size of 4? So we have a sample size of 4. We know that we will have the mean of 20. But it seems like the sample size is actually quite small here. And so it will not approximately be normal is the one you actually want to go for. So A and B was definitely not going to be part of it. The mean and the standard deviation will be 20 and 5. Well, 20 is definitely for sure, but 10 and 5 between these two, the standard deviation is 10, which means I have to divide by the sample size always to have this to find out the sample standard deviation. So that should give me 5, but the shape of it will not be normal because the sample size is just too small. Number 9, random sample is to be selected from a population for which combination of n and p is reasonable to assume. That the sampling distribution will approximately be normal. We just want to do this. Make sure that you also check for this. Both of the conditions must check in order to assume normality. I believe that this one will not work. Neither will this one. Neither will this. Neither will this here. And the only one that's actually going to work. Let's see here. Oh, I'm sorry. Yeah, I believe B is the only one that actually works because 25 times 0.5 is actually 12.5 here. So that's 12.5%, I mean. I'm sorry, not percent, 12.5 exactly. So that's greater than or equal to 10. So this is the only thing that works. E, 100 times 0.05 is 5. So that's cutting it short. So 9 is B for that one. Number 10, suppose 50% of those taking national licensing exams. So we have P equals 0.5 and is equal to 100. And P hat is the proportion in the sample. What is the mean of the standard deviation? Well, the mean here will just be 50%. So we're not going to take anything less than 0.5. The standard deviation is P times 1 minus P over N and square rooted. Please remember the sample proportion standard deviation. 0.5 times 0.5 over 100. And when you square root that, you get 0.0025. And then you have to square root the whole thing. So that will end up being C. 11, for which of the following will the sample proportion tend to differ least from sample to sample? So differ least means that it's going to have the smallest variability here. Now, also, again, 11 is one of those questions where it tends to get a little tricky, but let's try to eliminate many choices as possible. Let's say you're faced with this question on the day of the exam or on tomorrow's test. What you're first going to do is eliminate A and D. The reason for that is because A and D can be countermeasured by the answer choice B and E. Notice how answer choice A and B and D and E are pretty much exactly the same, in respective to its own categories, with probability of 0.1 and probability of 0.5 but the only difference is that the sample size, one of them is bigger than the other. Now, as we discussed earlier, as sample size increases, your variability tends to decrease. Therefore, D is out and A is out because higher sample sizes means lower variability, and that's what we're looking for right now. Honestly, amongst B, C, and E, what you want to do is you want to pick the one that actually, what I like to call having the probability on the edge. When we draw the probability, I'm sorry, the sampling distribution for proportions, we differ between 0 to 1. It's from 0% to 100%. Let's say the middle is about 50. 0.1 means that it's very, very close towards the left-hand side. And most likely what's going to happen is you're going to have a distribution that is actually skewed to the right. Now, why would that be in favor to having, variability being low? Is because all of the data will be congested around that. And there's no spread towards the left-hand side because the center is so it's so close to the edge. Notice how the center is towards the left-hand side. The left part of that graph, it can't go below 0 because the probability can never be negative. So the variability amongst these is actually quite low. Versus E, even though the sample size is bigger, I mean, this is N is 40 and N is 60, which obviously 60 is much bigger, but it's not significant enough to actually make E to be the correct answer choice, because if I were to draw out what E is going to be, 0.5, it's right down the middle of the probability sampling distribution. So if I were to draw the normal distribution curve, I mean, notice how big enough spread that will be because the center is right down the middle. Therefore, the lowest possible variability that if you're looking for the probability to be closer to the edge so that all the probability sample proportions will be congested in that area. So the correct answer here would be B. Number 12, which of the following is true? The sampling distribution P hat has a mean equal to P. Now, first of all, you need to check that off. The sample proportion will always equal to the population proportion with many simulations there. The sample distribution P has a standard deviation equal to this. Now, I think they made a mistake in saying that has to be divided by N. The sample distribution P is always symmetric. That is not true. It could also be skewed to the right. I mean, skewed to the left. It's only a matter of having a big enough sample size so that N times P is greater than or equal to 10. Once that satisfies, it now becomes symmetric / normal. So the correct answer here would be A. 13, as the sample size increases, how does the sample distribution of mean change? The mean of the distribution decreases in value. The standard deviation decreases in value. So as this increases, the standard deviation should decrease. So that should be B. With the rest of them, increases in value, that's completely the opposite of what I'm trying to say. They will definitely change. So it's not E. The mean of the sample distribution increases in value. It has nothing to do with the mean. The mean always stays the same. Number 14, if a population distribution is substantially skewed and the sample size is small, which of the following is true about the sample distribution? Well, if you have a skewed distribution, and if the sample size is very small, then your variability must be very large. Because we do not have a normal distribution curve from the get-go, and because the sample size is too small, notice how if they emphasize on the word small, we can't really assume this central limit theorem to be the possible case, because central limit theorem only applies to sample size being substantially big enough so that it can be assumed that it's going to be normal. Oh, sorry about that. All right, so which of the following is true about the sampling distribution of mean of X? So there, what this is going to be is that it's the shape is not approximately normal is the one you want to go for. So you want to eliminate A and E. Why? Because it's substantially skewed and you don't have big enough sample size. Okay, so amongst these guys, which is the best choice? The mean will always equal the population mean. So please, that the answer for these types of questions will always be D. Now, this actually is true. The only problem is that they are not equal to each other. So that's what the problem is. So the correct answer here is D. 15. The mean of a population is 83 with a standard deviation of 5. Sample size is 40. So what is the mean and the standard deviation? Please eliminate E since it doesn't have the 83. I mean, coming from the question 14, the mean of the sample should always equal the population mean, regardless of the shape of the distribution. So with amongst all of these, which one is the best choice? Obviously C, because it's the standard deviation divided by square root of n. That's always the formula. Number 16, as a result of the recent recession, I believe I've done this question with you guys during the class. This is an example of a statistic. 72,000 is a measure of this sample size of 50. So the sample size n is equal to 50. That is what that is what's defined as the number 50. But if we're talking about 72,000, that is the measurement of those 50, I think, house sales in a large urban community. So that is a statistic. Parameter and population, they go hand in hand together. Population will be, in this case, all of the houses in the United States and their home values. And parameter will be the home values, and population is all the homes in the United States. The proportion is obviously P, proportion of, 0, it will give you decimals or fractions in those regards, but since I don't see any of that stuff, it's not any of these choices here. Number 17, population is has a mean of 78, standard deviation of 4.8, sample size of 100. I don't think it needs to be set. It's going to be B. The standard deviation divided by square root of n is always the standard deviation of the sample. Which of the following statement is true? The mean of any sample always equals the mean of the population it came from. So for 18 here, Roman numeral 1, yes, so the mean is going to be true here. The sample distribution of means is a roughly normal shape. About the population mean, when the sample size is sufficiently large, that is also true, because using the central limit theorem, because when they specifically say that n is sufficiently large, that's kind of your cue to say, oh, so I can use central limit theorem for this thing. As the sample size increases, the variation of the sampling distribution of the means decreases. Yes, this is absolutely true here. Oh, I think I made a mistake because I checked all three. The mean of the sample size. Oh, right. The word always. We always want to take avoid. I thought it was just going to be all the samples, but any sample means that it's just one sample there. So if you take one sample of it, and when you take the mean, it shouldn't, or it can, but it's not always equal to the population where it came from. I mean, it could be, because that's why sampling variability exists. The samples could differ from one to the other, and their means could be different. So the correct answer here should be 2 and 3. 18 should be, yep, E. A certain population of 7 numbers has a mean of 8.5, standard deviation of 2.29. I have a sample size of 3, which means I take that standard deviation divided by square root of 3. Dividing by any number that's bigger than 1 means it's going to be a smaller, so it's going to be C. Please eliminate D and E because your sample mean should also equal the population mean. The central limit theorem states that when n is sufficiently large, the sampling distribution of mean of x is roughly approximated by the normal curve. That is literally the definition of what central limit theorem states. If the population distribution is normal, well, it doesn't really talk about the population distribution. I mean, it could be skewed, not normal for all I care. It's really determined by, as n is greater than or equal to 30, then you can assume normality from that. And if the population distribution is normal, then it's safe to assume that the sample will also be normal. So you don't need to have a large sample size in order for you to get normal distribution. So it's literally A. That's the definition here. 21, a sample of 36 kindergarten children has their heights measured. They are found to have an average height of 37.2. What can be said about the population? So the population should also have 37.2. So D and E would be smaller or larger than 37.2. We're not going to take anything more or less than 37.2. The standard deviation is 6 times smaller than the sample standard deviation. The standard deviation is 6 times larger, and the standard deviation 6 times larger than the sample deviation. The population will also be normally distributed. So for this type of questions here, well, I have n is greater than or equal to 36. So we can assume normality, I believe, from here, because using central limit theorem. Oh, I'm sorry. This is population, not sample. So I can't have population will also be distributed because they didn't tell me that the distribution of the kindergarten children is normally distributed. The sample distribution can be normally distributed, approximated by that, because the sample size is big enough for us to assume that. So C is going to be out because we have no information about the population distribution. So really between these two, you have to end up using algebra. We have a standard deviation, which we don't know, but it says it's 36 kindergarten children. That's the sample size. So you're literally taking the original standard deviation, dividing it by 6, and that's going to be your sample standard deviation, which means if you just multiply both sides by 6, the original standard deviation is 6 times larger. It's multiplied by 6. So the standard deviation is 6 times larger than the sample standard deviation. That is the correct answer. So 21 should be B. 22, a simple random sample of 1,000 Americans found that 61%. So I'm going to write 0.61 service provided from the dealer. Simple random sample of 1,000 Canadians found that 58% were satisfied. When the sampling variability associated, sampling variability can be measured by the standard deviation. So let's find out the standard deviations for the Americans and the Canadians alike. So standard deviation of, let's say, Americans is, because I'm given proportions, P times 1 minus P over N. Canadian square root of P times 1 minus P over N. When you plug in those numbers accordingly, let me pull out my calculator here. So let's take a look at the NJSLA practice test. So here, all right, so on the calculator, I'm just going to type this in. So 0.61 times 0.39, sorry, divided by 1,000. And I'm just going to square root that answer, and I get 0.0154. Now I'm going to do the same thing with 0.58. So 0.58 times 0.42 divided by 1,000. Square rooting that number, you get, oh, I mean, look at those two numbers, 0.0154, 0.0156. They're so close to each other that it's about the same. The sampling variability, in other words, that's a fancy way of saying standard deviation, they're approximately the same as proven by the calculator here. All right, so number 23, it is believed that currently 37% of Americans have at least one flat screen television in their homes. A sample of 150 Americans surveyed. What is true about that sample? So the sample size is 150, and it seems to me that you're supposed to be using the standard deviation for proportions, which states as P times 1 minus P over N, square root the whole thing. I think during second period, I just made a mistake to saying that B and E is the same, but E is the correct answer because it has a square root over the whole thing instead of just the numerator. Obviously, all the other ones makes no sense. It's going to be E. 43% of the people in particular county are Democrats. A sample of 200 people is collected. The approximate probability, guys, whenever they are asking you to find the probability, you're just going to use the normal CDF, normal CDF, and you're going to be on your way. So here, they tell me that P is 0.43. More than 100 people out of 200, well, that means 0.5 and above. Second varus, normal CDF. Now, the lower here will be 0.5, and the highest possible chance it's going to go up to is 100%. With the mean being 0.43 and the standard deviation of, well, that also we need to figure out, right? So standard deviation of the sample proportion states that it's P times 1 minus P over N. Plug in all those numbers. 0.43 times 0.57 all over, what is it, 200? I feel like I can just, it seems like the calculator here is not working. Let me just see if I can just access this one more time. Okay, so NJSLA practice test. All right, so here, I'm just going to type this in first real quick. 43 times 0.57 over 200, and you square root that number. So 0.035, give or take. Second varus, normal CDF. That's going to be 0.5. That's 1. That is 0.43. And that's 0.035, give or take. And then once you type it in, so it's about 0.02275. So the correct answer here should be D. And 24 is indeed D for that reason. Number 25, we have university states that 14% of their students is most likely to have a full-time job. So what is the minimum sample size in order for you to get a normal distribution, or you can approximate the distribution by normal curve? That is just this, guys. N times 1 minus p is greater than or equal to 10, and n times p is greater than or equal to 10. So you just want to check for that. You can see how ABC makes no sense. By plugging in 10, 11, 12, multiply by 14%, there is no way you're going to get anything close to being greater than or equal to 10. So let's try 71. 71 times 0.14 into the calculator. So 71 times 0.14. And unfortunately, it doesn't cut it. So 72 times 0.14 is greater than 10. Not only that, but 72 times 0.86, which is the other portion of 100%, that is also greater than 10. So you have to have at least 72 students before you can assume normality there. All right, number 26. A news magazine claims that 30% of all New York police officers are overweight. So that is your proportion. That is your sample size. And this is your sample proportion that you found. What is the best explanation here? The correct answer here should be C. And here's the reason why, as I already went over with you guys during the class. This must be wrong. Always avoid those words as this must be. It can happen. It's a sample proportion. The sample was not large enough. Guys, 200 is a very large sample size. There's no way you're going to be classifying that as small. 26% is just one of the sample proportions you got out of the possible 200 sample sizes. So that is possible. 26% is just a statistic. The normal curve is not a good approximation here as the distribution is right skewed. True, it is skewed, but n times p is greater than or equal to 10. N times 1 minus p is also greater than or equal to 10. So you can assume normality for this. No questions asked about that. The standard deviation of the sample will not be this, unfortunately, because it's 0.3. That is the proportion you want to use to find out the standard deviation. Oh, sorry. So then that would be 0.3 times 0.7. I think it's just registering some technical issues of difficulty. It seems like it's saving image for some reason. I'm not sure why. Just going to delete PDF for now and see if it saves. Okay, so I think I was... All right, so I pretty much lost all the progress that I had before, but I was on this question, and hopefully you guys have, all the video recorded everything. So the correct answer here, oh, I'm sorry. The correct answer here is C. I was talking about E. So E, it's wrong because these two numbers has to be 0.3 times 0.7 in order for that to happen. In order for this to be the correct answer. So that answer choice E would be wrong. So the correct answer here would be C. All right, so I'm going to stop here for part 1. It seems like I have such a long way to go that I want to cut this video into 2. I will upload the second video shortly. And so then the next part, I will go over questions from 27 all the way down to 48.